let's get started with Bryan from Coursera. Bryan, please.
Hey everyone, I'm Bryan. I'm a software engineer at Coursera on the front-end infrastructure team. And I'll talk to you a little bit today on declarative GraphQL, basically how we adopted GraphQL and added GraphQL to all of our APIs without actually writing a single resolver. So I guess give you a little bit of context for those of you who aren't familiar with Coursera. Coursera is an online education company. We partner with the world's best universities and the best companies and work with them to take their courses and produce courses with them and put them online for anyone in the world to take. We've been around for almost 5 years now. We've had thousands of courses. We have, I think, 25 million users and millions of course completions. So we're really trying to revolutionize online education. And as we do all that, there's a lot of different products that we need to build all the time. So of course, we need to build a whole bunch of APIs to be able to support all these products. So I'll give you, I guess, a little bit of context on the REST APIs at Coursera and kind of our evolution over the past 5 years that we've been building Coursera. So right now at Coursera, we have 584 different resources. You consider a resource it's one-to-one with a model. So you could imagine like a course resource, an instructor resource, a quiz resource, a course grade resource. All of these different kind of entities that we call resources. And then on those, we have 1,352 different endpoints. So you can imagine for a course, we might have different ways to actually get that data. You have lookup by an ID, you have lookup by slug. Maybe you could get like all of your enrollments or all of your courses that you're enrolled in. So we have different ways of accessing these different resources through these endpoints. And all of these are split up on 70 different services. We don't really like to use the term microservices because it has kind of a bad rep, but we call them like medium-sized services. So it's split up. We try to keep everything pretty siloed, and services and things that make sense grouped together will go together. Like one team should own a service completely. We don't try to have things split up on 2 different teams owning the same service. So try to just keep it logically separated. We actually do all this with just about 30 backend developers. So there's a lot of services to maintain, a lot of APIs to write, and not too many developers to actually maintain all of this and keep building these new APIs. So over the years, we've been building a lot of APIs, and we realized that we needed to come up with some better way to actually be able to write all these APIs, and something that would let us do it faster, more consistently, and just easier. So we actually built a framework called Naptime. It's a REST framework. It's a terrible name. I'm really sorry about that. Not my fault. So Naptime is basically a library that we made that lets us kind of abstract a lot of the basics around building an API into a common library, so we don't have to think about so many things every time we're building an API. It just makes it a lot easier to build these new APIs. So some benefits that gives us, all of our APIs are very consistent with Naptime. All the requests are in the same format, the responses are all in the same format, pagination's handled in a consistent way. These are things that we don't have to think about every time we're building a new API. And we like to say that once you know one Naptime API, you know all of them. It's a much lower cost when you're building these new APIs because you don't have to think about all these things every time you're building an API. You don't have to come up with your pagination model. You don't have to think about how you're going to do authentication, authorization. And because we actually have all this boilerplate abstracted away, you don't actually have to write that code. You just have to worry about the core functionality of your API, how to get that data and return it. You don't have to worry about all those other things. And because we're using Scala for all of our APIs, we get this type safety and we get a lot of correctness checking built in at compile time. So we can never have an API that looks like a get but returns multiple elements. We can't ever have an API under the courses API that returns an instructor. So we check that everything is actually in the correct format and works the correct way at compile time, and just make sure that all of our APIs are very consistent. But we built this thing called Naptime. It worked out pretty well for us, but there's just a lot of things that it can't even handle. And mostly REST's fault, some of it's our fault, but there's just a lot that it wasn't doing for us. So one big thing is just loading related data. So for example, if we have a course page, you want to get the course information. We also want to get the instructor information. You want to get the university information. You could either make an API call, get the courses, that comes back. Then you go fetch the instructors, then that comes back. Then you go fetch the universities. And that's just really slow for the users. Or you could try to come up with some weird syntax. We tried this, where you could have a URL and you say, I want to get the courses and include the instructors on that, include universities on the instructors. And so we ended up with like super long URLs that were actually longer than the HTTP limit. And developers were trying to actually construct these URLs by hand. We had to write libraries around that. And eventually just took a step back and we were like, that's ridiculous. Another problem is API discovery is really hard. So you build an API, you think it's really cool, you give it to the developer that's building a product. But 3 months later, if another developer on another team needs to use that same API, if they can't find it, they won't know that it's there, and they'll go ask another backend developer to build that API. So we've had a couple cases where we have like multiple APIs serving the exact same data, just with different names, because the developer didn't know about it. We also have so many times when a client developer needs to like get profile information. So then they'll go to Slack, they'll ask the entire channel, how do I get profile information? Everyone jumps in with different answers, and there was no like easy way to figure out what API to use for all your different things. Also, communities are just super important. When you're trying to build a library in-house, it's one thing to actually build that library, but maintaining it, writing the documentation, doing support, all of that is super expensive, and it really adds up. Another thing we like to refer to as like Googleability. When you're onboarding new people, and like we've had developers come in and they're using Naptime, and they're like, oh, this is cool, but I don't know how to do something. So they'll Google like Naptime tricks or like how to use Naptime. They'll get information on how to take a good power nap, but they're not going to get information on how to actually use our library because no one else in the world knows about it. So we kind of looked at all this, and these problems were kind of coming up over the years, and we realized that there needed to be some other option out there. And I guess you could probably guess, because I'm here, you're all here, GraphQL. So I'll talk a little bit, I guess, about how we've made the journey to GraphQL. So I guess taking a step back, why we chose GraphQL on top of all the obvious things. Really, those 3 problems that I mentioned, it really solves all of those for us. So with graphical, API discovery is so much easier. If you want to get information about a course, you either search on the right-hand side where it loads all of your documentation, or you just type course and you're going to get the autocomplete of all the different course APIs available. So developers don't have to like figure out what our APIs are available, search through the code base or anything. They just go to graphical and immediately find that out. Also, nested data and related data, it's much more intuitive. You don't have weird URL syntax or anything. It looks like what you would want it to look like. And the fact that there's a standard and a spec behind it is huge. I mean, everyone kind of had their own interpretation of what they wanted REST APIs to look like, but no one was actually correct because there is no correct thing. Having some concrete thing that says, this is GraphQL, this is how it should be, this is the structure behind it, just made it so much easier for us because we didn't have to come up with all of that on our own. So we looked at all this and we were like, okay, GraphQL is definitely something great. We want to move to it. But how do we actually get to GraphQL? It's not actually that easy. You can't just do like npm install GraphQL and suddenly all of your APIs work with GraphQL. So you have to kind of adapt it to your APIs in a specific way. Most people, when they get started, they probably install like Apollo server or some other GraphQL server, and they'll then define resolvers that say, okay, I have a course object in GraphQL, and I need to get that data from my existing course API, or I could get it from the course database, or I could do some business logic there to get the course. But we have these like 500, 600 different APIs already there, and we didn't want to go in and write that all for each one by hand on how to fetch all that data. Mostly because developers are lazy. They really don't want to go in and just rewrite this thing. We made Naptime easy for them because they didn't want to handle all that. They want everything solved for them so they could write the actual business logic and the stuff that matters. They don't want to go write some more extra things just to get their API working when it was already working in REST. It also requires keeping different services in sync. So if we built this one like GraphQL layer and we add a new API in there, we have to then, every time we update one of our APIs in a service, we have to go update this GraphQL layer also. And we like to really keep our services very self-contained. So if developers want to deploy forward, roll back, shift 50-50 traffic, there are a whole bunch of different things they could do inside their service. But if we had to then keep 2 services in sync, that becomes much more difficult. Lastly, schema design could be very inconsistent. So if we told developers they should go write their own schema on how they want their data to be accessed, you could have 2 different teams with 2 different interpretations on what their ideal schema looks like. And we saw there are so many benefits with Naptime, and we kind of figured that out once and everything was consistent. And we didn't want to get into that with GraphQL again. So we kind of did what any good developer does when they look at the problem and they realize that they're doing the same thing over and over and there isn't good option. We automated it. So with Naptime, we get actually 3 very important things that lets us kind of automate this transition to GraphQL. The first one is we get a schema that has all of the available endpoints. So we have like the courses v1 resource, instructors v1. We actually, because we're using Scala and everything is at compile time, we can generate kind of like a JSON file that says this courses v1 resource is available on the catalog service and tells you basically where everything is. It also tells us a lot of the input parameters. So course resource will have a by slug finder that takes in a slug parameter that's a string. So we get all that detailed type information. And lastly, we get schema definitions for all of the response bodies. So everything that comes back from that API, we have a schema that defines the type. We use our own, it's based off LinkedIn's RESTly, it's called Courier, but it actually maps pretty much one-to-one with GraphQL. So it has primitives in it, it has record types, unions, enums, all of the things that you'll find in the GraphQL schema. We actually had that already for all of our response bodies. So we took all that data and we kind of just adapted it to GraphQL. So we built a service that does 2 different things. It goes in, every 5 minutes it hits all of our services, it gets all the schema information, and we build a unified GraphQL schema that takes all the information we know about the different endpoints available, the different resources, and the different request and response types. And we build this schema that basically represents the state of all of Coursera's APIs. And then we built a generic resolver that, given anything that comes in from this schema, we know how to go resolve it because all of our APIs look the same, they work in the same way. We just built this single resolver that could take any input and go and hit our downstream APIs and get the data. And I'll just also mention, kind of as a side note, that we built all this on Sangria library. So if you're using Scala and you want to do GraphQL stuff, Sangria is definitely the way to go. I don't know if there are other options out there, but you want to use Sangria. It does pretty much everything you need to do and more, and it's just really easy to use. And if you're not using Scala and you want to, there's a Coursera course for that. Go check it out. So I'll talk a little bit about our schema design. This was, I guess, somewhat controversial when we were first coming up with it, but it's kind of worked out pretty well for us. So we have 3 different kind of main things I'll point out. The first one is, I guess, the response body type. So all of our REST APIs were in the format of, there's a model name and then a V and then version name. So we kind of adapted that to look a little more like GraphQL. So we'll have a courses v1. If we needed to do some sort of like very backwards incompatible thing, we can make a courses v2 in there. Sometimes it happens. Yeah. And then we have this courses v1 resource. So this is different than what most of you would probably expect, where it's actually, this is embedded in the root, and it's basically an object that has a collection of different ways to look it up. So you don't just go directly from the root to get your course. You would go through this courses v1 resource, and it has these different handlers on the course endpoint where you could get the course information. And then the connection's pretty basic. It has elements and it has pagination in there. So as I mentioned, there were these kind of 2 options that we were looking at in developing our schema. First one is where we have everything nested in this like courses v1 resource. And the other option is to take all these different handlers, the 1,300 of them, and put them on the root. And I mean, both options have their pros and cons. Some of the pros for the one in the bottom right is it looks a little bit more like GraphQL. You don't have to jump through this extra layer to get to your data. And on your root, you could just do anything you want. It's much easier to kind of just jump directly to get the data that you want. But some of the problems with that is we didn't have any way to kind of generate these names automatically. So it would require developers to go in and define like the main root name for all of these handlers. And we didn't want to give them extra work. Another thing is a lot of these names, it might be more difficult when you're trying to figure out how to get the data. If you're going through 1,300 options, there's a lot more there. So if we named everything that was a get all, starting with the word all, and you start typing all in GraphQL, you'd get a list of like 500 different options in there. That was a little scary for us, and we wanted to make it a little bit easier for developers. So with the way of nesting everything in this courses v1 resource object, if you know you need to get a course, and most of the time developers right now are still thinking in terms of, I know this REST API, how do I get it in GraphQL? So they type in courses v1, they see that there, and then they see all the different ways to get the course. So it makes it much easier for them as they're kind of going through this, and it makes it much easier for us as backend developers, that we don't have to add this extra work in to get everything working with GraphQL. So this was pretty cool. We kind of built the service and ran it, and all of a sudden we had a giant schema. I think it was like 30,000 lines long. It was very long. It had basically all of our APIs and everything in there, and that was really cool. We went to graphical and everything worked. It was awesome, but that was only really half of it. I mean, one of the main benefits that I mentioned earlier with GraphQL is that it lets you link everything together in a really easy way. And by just converting our basic REST APIs to GraphQL, we didn't actually get that yet. So we really wanted some sort of query that looked like this, where we could get the course information, then we get the instructor, we could get maybe the university on the instructor, you get your enrollments in there, basically everything you need all in a single query. So some of the problems, we were kind of thinking about this problem and we didn't really know exactly how to solve it. One big thing that is important for us is we treat all of our backend APIs like a black box. So if you're doing something where you have a relational database and you want to get the data out of there, that's really easy. If you want to get courses and instructors, you select your courses, you join on instructors on a certain field, then you get everything there in one statement. There's no way to join across APIs easily. You have to go and fetch the data individually. Another problem is that we had no control over our backend systems. Because we have all these different services and we like to give teams as much independence as possible, we couldn't make any assumptions on how the backend services function. We couldn't assume that they were using relational databases and they could take hints on like how to join things. It was just the API that they gave us was we get this resource, we have the ways to get it, and that's all that we know. So, I mean, most of our data is actually stored in Cassandra, which is NoSQL database. And in Cassandra, if you want to be able to look up by something, you have to explicitly make an index before you store your data. You can't just like create a course and arbitrarily look up by the course title unless you know that you want to look it up beforehand. So if there was no API available to look up by title, there was no way that we could actually get that data. We also really want to keep the services as independent as possible. We didn't ever want to have, say you want to go from courses to instructors, we didn't want the course resource to have to know about the instructor if it didn't already. We didn't want the resource to have to then go make an API call and get the instructor information and like include it in the response. We really wanted everything to be as independent, as siloed as possible. So as we were kind of going through this and thinking about the different approaches we could take, we realized that there were kind of three different problems that we were trying to solve. There were three types of ways that our data is related. First one we call forward relationships. These are pretty basic. So you have two models, like a course and an instructor. In this case, for a forward relationship, the course would know which instructors are in the course. So you have maybe an instructor IDs field on the course. So then it's very easy to know from the course which instructors are part of it. The next one we call reverse relationship. That's when Model A doesn't know about Model B, but Model B knows about Model A. So if you have a course relating to instructors, it might not know about the instructors in the course, but an instructor might know about the courses that they're part of. And the last one is when there's just no relationship whatsoever. Model A doesn't know about Model B, and Model B doesn't know about Model A. So I'll talk a little bit about how we kind of solve these three different relationships. First one, forward relationships, these are pretty easy. You know from the course how to get the instructors, so you have all the IDs, you just fetch that data. So what we did is we came up with this kind of syntax to add onto our courses resource to be able to define courses resource has related instructors, and this is how you fetch the information. So you'll see we made kind of a multi-get relation. We came up with just names for that, and it specifies that the resource name is instructors v1, and it specifies how to get the instructors for it and includes some extra arguments. So a couple things to point out here is we didn't actually write any like imperative code on how to fetch the instructors. We just defined the different properties about the relationship, and then we're able to use that in our GraphQL service. Another thing, it's a little strange, but we're kind of okay with it, is that the IDs field, you'll see that it's kind of a quote and there's $. We do some sort of string interpolation in there just to give developers a little bit more power. Sometimes you have a Model A, and to get the ID for Model B, you have to combine two different fields in there, or you add like it's a course colon in the course ID. Come up with some strange IDs, and we basically just need to compromise and give developers a little bit more power on how to go from Model A to Model B. And lastly, we have arguments in there. This is pretty similar to what you'd expect with REST. If we need to specify some extra arguments on how to look it up to get the instructors for the course, then we let developers put that in there. So next, talk about reverse relationships. These a little more complicated, but it's not actually that bad. The way that we do that is we give resource B the responsibility of returning its matches based on some information about model A. So if our instructor knows which courses they're in, then we could build a way on the instructor resource that, given a course ID, it could return all the matching instructors. And then in resource A, we just specify how to look it up based on that. So in this case, we have kind of a finder reverse relation that still goes to instructors v1, but it looks it up by course ID, and then we specify the course ID is going to be the ID from the course. So it's still pretty easy for the developer, if they're adding this in, to just specify in a couple lines how the relationship works. And the way that this actually works on our backend is every time we get a call from the course, if we want to get related instructors, we just call this REST API, and we get the instructors that match that course ID, and then just add that data in there. And lastly, the resource is no connection. We realize that this isn't actually a problem that we need to solve in GraphQL. Basically just need to build a new resource to combine the two things. So you might have a course instructors resource that would have a by course and by instructor finder on there. This isn't something that we needed to really think about in the GraphQL land. There are other ways around it. So as we built all of this, we kind of adapted it to all of our different APIs. And we learned a lot, mostly around developer experience, what would make it the easiest way to transition to GraphQL without kind of disrupting too many things. And the first thing that was super important for us is declarative over imperative. So GraphQL is super popular on clients because client developers, they don't want to know or they don't need to know how to go fetch the data. They specify the data that they want and then trust that there's some other system that will get them that data. That's why, client developers love GraphQL. They write that they want the courses, they write that they want the instructors, and then it all just happens for them. We really wanted that also for backend developers. When we're defining these relationships, we didn't want to have backend developers write how to go from the course API, go fetch the instructors, and how to link everything together. We just wanted them to say, we have a course, we have related instructors, it's related on this field, go work your magic. Next thing is large migrations are really expensive. And this might seem kind of obvious, but it's something that we really tried to think about a lot as we were doing things. So we're kind of working through now on adapting a lot of our client code to switch from REST to GraphQL. And it's not the most difficult thing, but it's definitely taking some time, and it's requiring a lot of weird stuff here and there. And we really didn't want to have to pay that cost again on the back end. If we went to our director of engineering and said, hey, we really want to move to GraphQL, we know it's the right thing to do, but we're going to have to go and pay this cost on the front end, migrating REST to GraphQL. And we're also going to have to go rewrite a whole bunch of APIs or add some new things in here to get all of our backend APIs to work with GraphQL. You'd probably just look at us and think that we were crazy. So we need to kind of make some compromises and find easier ways to do this without making all of our developers pay the cost. Lastly, this is kind of has a couple names. I've heard like GraphQL first, I've heard wish-driven development, but a lot of things at GraphQL, you really want to know your schema before you start building your product. This is true when you're building a new product. You want to maybe define your GraphQL schema before you build your front end, before you build your back end. But this is also actually applied for us too. So initially, we actually built our assembler GraphQL service without support for reverse relations, because we looked at some of the code and we were like, oh, we probably don't need that. Well, developers will find ways around it. It's fine. It's going to be too much work. But if we actually looked at all of our schemas for all of the products before we actually built this, we would have seen that we definitely need to build something like this. There was just no way that we could get around it. But we did some work on scoping out our schemas before we built this, but we could have done a lot more around figuring out all of our ideal schemas and then building the GraphQL product from that. So those are kind of the main lessons that we've learned. There's still a lot more that we're doing with GraphQL. This is kind of only the beginning. We have a lot of products to migrate to GraphQL, a lot of people to ramp up to GraphQL, but really excited on all of the potential that it gives us and all of the opportunities that we have now that we didn't really have with REST before. So with that, I'll just make a very quick plug that we're always hiring. So if you're interested in working on GraphQL stuff, want to use it building products, want to build some infrastructure stuff, there's some really cool things we're doing. Come talk to me later. And thanks very much. Time for questions.
Awesome. So we have a couple minutes for some questions. Does anybody have any questions for Bryan?
Do we do anything for N+1 fetching issues? We've done a little bit. So we try to optimize whenever possible. We have multi-gets on most of our resources. And We very strongly encourage that developers build these multi-gets, and we try to batch everything together from our assembler service. But some cases with like the find reverse relations, we had, I guess, one API call for every single element in there. That isn't the most optimal. We try to expose that when possible through like complexity scores, but we haven't optimized that too much. Is that what you're asking?
Yeah.
Okay. Yeah.
How does it scale? Do you have any caching strategies?
The question was, how does it scale in caching? So at first, no caching. Most of our APIs aren't cached just because there's a lot of other work you have to do around caching. Every time someone makes a change in one service, you might have to go update another service. So we try to build most of our APIs to just be fast and not require caching. So we've kind of taken the same approach for now in our GraphQL service. We don't actually cache anything, and we assume that our services can handle it. We could maybe scale up if we need to. If it becomes an issue, I'm sure we'll come up with some approach around it, but so far we haven't needed to. Okay. So first question was, how do we do metrics? With the Sangria stuff, we've actually just been able to add like different filters and plugins in there. So as the request comes in, we're kind of adding in different, we use Datadog for all of our metrics. So we basically add different API calls in there just to record different timings in there. So we have like median latency, P95, P99. We keep track of also number of failures, I think we have number of entities in our GraphQL schema, just some basic things around that. The second one was around versioning and basically how that's worked. That's kind of something that we kind of just got when we converted from the REST stuff to GraphQL. So most of the time we try to do backwards compatible things when possible. But that's not always the case if like some fundamental logic change or we need to like create a completely new model. So this is basically just allowing us to adapt these REST endpoints to GraphQL. We kind of have to take that version in there and just support both of them. We could maybe do something around only supporting one and choosing which one to support, but that would remove a lot of that automation from there.
Cool. Thank you, everyone, for the questions. Thanks again, Bryan, for speaking.